Hello. So in this video, we're going to discuss another example of volume of revolution for a curve. So let's look at this. Find the volume of the solid form by revolving the region bounded by this graph, right, about the y-axis. So of course, the sketching of graph is very important. So we know that y and the x-axis here, we have graph of x squared plus 1, right? X squared plus 1. So x squared plus 1. So, and the line x equals to 1, right? X equals to 1, so means 1. So there is a graph. So 1, right? This line, x equals to 1. So x equals to 1. And x-axis, right? Bounded, the region bounded by the curve, the line x equals to 1, the x-axis and the y-axis. Alright, so this is the region that I'm going to rotate. Alright, this is the region. So let's look at this region carefully. Now because we want to rotate about the y-axis, right? Y-axis. So it's different from you rotate through the x-axis. So if rotate through the x-axis, okay, for example, this question they're asking you to rotate about the x-axis. So the volume of revolution will be writing in this way. If we rotate through the x-axis, so it will be pi integrate dx from 0 to 1, because now we rotate through the x-axis, right? So the limits we take 0 to 1. So which is the graph of y equals to x squared plus 1, right? X squared plus 1 to the power of 2. Then we carry on with the integration. We will find out what is the volume, right? As the volume form here will be very different, all right? As you look at this region, right? This region, if you rotate through x, if you rotate through x-axis, so this will become your axis of rotation, right? Axis of rotation, x-axis. So they will form a solid in this way, right? This will be the solid. This will be the solid form, right? If you rotate, this will be the solid form. But if you rotate through y-axis, the volume, this is rotate through x-axis, right? You rotate through x-axis. So if you rotate through y-axis, right? Rotate through y-axis, then the solid form will be, okay, let's look at this. So it will be forming such that there is a hemisphere here, but it's not actually a hemisphere. So, and here you have a cylinder. You have a cylinder. All right. So this is the solid form. All right. So with here empty, and this one is revolving. Alright, this thing is revolving. So this solid, the volume for this solid and this solid will be different, right? Because this is rotate about x-axis and this is rotate about the rotate about the y-axis here. So let's see what's okay. Now I have tell you that if rotate through x-axis, this will be the correct way of define the volume. So now let's look at volume rotate about y-axis, right? Rotate about y-axis. So then we're going to see that this is actually, can you see that? There is a cylinder here, right? Okay, it's a big cylinder. Okay, I'm going to draw it out. It's actually a cylinder, a full cylinder, minus away a bowl here, right? A parabolic here. So it means that you are minus this away. This will be empty. While you're rotating this part will be empty. Alright, this part will be empty. And below here will be a solid. So how? I'm going to calculate the volume of the cylinder here. So as this will be your height, right? This will represent your height. So let's use some concept of geometry. So height here. So during one, when you substitute 1 here, 1 square plus 1, 1 square plus 1, you have 2 here, right? So it means that the height here is 2 and the radius here is 1, right? This is your radius. As you rotate here, this is your radius. So it means I'm going to use the concept of cylinder, pi r square h, where your r is 1, right? Your radius, if you rotate, this will become your radius. So 1 h square. 1 square h is 2 pi r square h. So it's actually 2 pi. So when you rotate, this thing is actually pi r square, right? The radius here is square. And the height here, how to find the height? I just substitute the 1 into the equation here. I have 2. So the height is 2. So now I have 2. And I have to minus the integration because this is a curve, right? So we're going to minus this section here, right? This section here. So this is from integration with respect to y as you rotate through y, right? Yes, no. So it means that I integrate with respect to y dy. So then I put pi here and have a square here, right? So then okay, let's look at this. It's from 1 up to 2, right? 1 up to 2. So 1 up to 2, x squared. As you dy, you have to find x squared. So then you already see that this is in terms of x squared. You write the x squared in terms of y. Y minus 1, right? Y minus 1. So means this is actually y minus 1. So you need x squared here. So as you see that the curve, if you write in terms of y, is already x squared in terms of y minus 1. So I just put the y minus 1 inside here. Then after that, I will take the volume of the cylinder, minus away this part here, right? The volume formed by this quadratic here. Then I will get the solid I want, all right? So then I have 2 pi minus with, for this is y squared over 2, y squared over 2 minus with y, right? Pi, so from 1 up to 2, right? So then I calculate 2 pi minus with pi as this, substitute 2 square over 2. 2 square over 2 is 4 over 2, which is 2 minus with 2. So you have 0, right? 2 square over 2. 2 minus 2, you have 0. Minus away 1. 1 over 2, negative 1, right? 1 over 2, negative 1. So finally, let's rearrange this. 2 pi minus with pi. And for this, you have 0. And this, you will have getting half, negative half, right? Negative half and negative, you are getting positive half, right? So you are getting positive half here. So as 2 minus half, you are getting 3 over 2 pi unit cube. So this is the volume generated, right? Generated by this region, all right? Generated by this region here, specifically by this region. So if you see, I take a cylinder, minus away this section here, right? So then I'm getting the volume generated. Okay, let's move on for the next example in the next video.